I am a really great Frisbee player. I'm so good that if you pick a spot on the floor, like you put a quarter there, I can toss my Frisbee, and 95% of the time my Frisbee will cover the quarter. And I can do it from any other place in the room. I can stand back here floor. If you put the quarter on the rug, I can toss my Frisbee and it will land on top of the quarter 95% of the time. So imagine that there's a quarter on the floor. I don't happen to have one, and I don't have my Frisbee with me at this point either. But imagine that I have, there's the quarter. It's the same color as the rug. You can't see it. It's not there. Well, we can do it with my pen. The pen is a slightly different color than the rug. And so I can stand back here, and I can toss my Frisbee, and 95% of the time it will cover the pen. So I've tossed the Frisbee, and it's floating through the air. What's the probability that it's going to cover the pen? 95%. So here's the Frisbee floating through the air, and I made a mistake and landed back here. What's the probability, now that it's on the floor where my feet are and the pen is there, what's the probability that the Frisbee is covering the pen? 0. So now, I have everybody leave the room except Rom. Everybody else has to go out. And Rom is going to pick the spot on the floor, and he's going to write down on a piece of paper the latitude and the longitude of that spot on the floor. You know, everybody knows what latitude and longitude are, right? That's the grid that's on the surface of the Earth, so you always know where you are. So he's going to pick a spot on the floor. He's going to write down on a piece of paper what the latitude and the longitude are for that spot. And he's going to keep it to himself. He's not going to tell you. You all, and he tells me, because I've got to know where it is. We call you all back into the room. I stand here, and I toss my Frisbee. It's floating through the air, it's floating through the air, it's floating through the air. What's the probability that my Frisbee is going to land on the spot that Ron picks? 95%. It's floating through the air, it's floating through the air. It lands on the floor. So the Frisbee is on the floor. Ron knows where the spot is, and I know where it is, but you guys don't. So you're sitting there, you're looking at the Frisbee on the floor. What's the probability that the Frisbee is covering the spot? 95%. Think back to the first sequence of questions that I asked you. 4. 100%. It's either 0 or 1, but we don't know which. This probability statement is wrong. Where is the random variable? There's no random variable here. It can't be right. You've got two numbers and a population parameter. It can't be right. And that's how the Frisbee example works. So mu is either in that interval or it's not. My Frisbee either covered the spot that Ron picked or it didn't. While it's still floating in the air, the method that I use for tossing the Frisbee is right 95% of the time. But once it's sitting on the floor, we're committed. There's nothing more, there's no more randomness to where the Frisbee is going to land. It's either on the spot or it's not. You've used a method in coming up with these numbers, you've used a method that's right 95% of the time. You don't know whether or not the one interval that you got was the right one. There are, I don't know, 4, 7, 8, 22, 26, 28. We lost some people. 31. There are 34 people here tonight. I have you all do the same numerical experiment that we were doing with student weights. You all go out and take a sample of size 100 cents. And you all construct a confidence interval for the mean weight of Temple students. Are any of you going to get the same interval? No, you can't. For the same reason that none of you are going to get the same sample mean. So we're going to have 34 different confidence intervals, even though you all did it exactly the same way. You looked up the same t-statistics out of the t-tables. Everybody has the same n, but you all got different x-bars and s's, contingent on the particular sample that you've got. However, what I do know is that it's pretty likely, it's pretty reasonable to believe that 95% of you have intervals that do encompass true meaning, because that's what we use. It might happen that none of you do, but I'm confident that 95% of you do. So I could say that I'm 95% confident that the sample mean is between 141 and 176. That's not the same as saying the probability that U is between 141 and 176 is 0.95. There's two different ideas. Okay, so don't forget you have homework due 2 weeks from tonight. The coverage on the midterm, by the way, will be whatever we get through to that point. I'm not going to write an exam that covers material that we haven't talked about in class. If you want, you have homework assignment that tells you how I write questions. There are old homeworks that tells you how I write questions. So there are plenty of opportunities for practice.
So that homework that we have, and as well as what we've gone through in the class, show you how to get a
That's a good estimator.
Yeah.